RAID stands for Redundant Array of Independent Disks, and it is a data storage technology that combines multiple hard disk drives, HDDs, or solid-state drives, SSDs, into a single logical unit. The goal of RAID is to improve data reliability, availability, and performance. There are several types of RAID configurations, each with its own unique features and benefits. Let's take a look at some of the most common RAID types. RAID 0. RAID 0, also known as striping, uses two or more drives to create a single logical volume. Data is divided into blocks and spread across all the drives in the array. This allows for faster read and write speeds, but there is no redundancy, which means that if one drive fails, all data in the array will be lost. RAID 1. RAID 1, also known as mirroring, uses two drives to create a redundant array. Data is written to both drives simultaneously, creating an exact copy of the data on each drive. If one drive fails, the other drive can be used to recover the data. RAID 1 provides excellent data redundancy, but it is more expensive since you need twice the amount of storage capacity. RAID 5. RAID 5 uses three or more drives to create a single logical volume. Data is striped across all the drives, but also includes parity information. If one drive fails, the missing data can be reconstructed using the parity information stored on the remaining drives. RAID 5 provides a good balance between performance and data redundancy. RAID 6. RAID 6 is similar to RAID 5, but it uses two sets of parity information instead of one. This provides even greater data redundancy, but it requires a minimum of 4 drives. RAID 10. RAID 10, also known as RAID 1+0, combines RAID 1 mirroring and RAID 0 striping to provide both redundancy and performance. Data is mirrored across two sets of striped drives. This provides excellent data redundancy and performance, but it requires a minimum of 4 drives and is more expensive than other RAID configurations. RAID 50. RAID 50 combines RAID 5 and RAID 0 striping to provide both data redundancy and performance. It uses multiple RAID 5 arrays and stripes the data across them. This provides good performance and data redundancy, but it requires a minimum of 6 drives. RAID 60. RAID 60 combines RAID 6 and RAID 0 striping to provide even greater data redundancy and performance. It uses multiple RAID 6 arrays and stripes the data across them. This provides excellent data redundancy and performance, but it requires a minimum of 8 drives. RAID controllers. RAID controllers are hardware devices that manage the RAID array and improve performance by offloading RAID processing from the main CPU. There are also software RAID implementations that use the CPU to manage the RAID array. Hardware RAID controllers are generally more expensive but provide better performance and reliability, while software RAID is cheaper but can impact system performance. Hot swapping. Hot swapping is the ability to replace a failed drive in a RAID array without shutting down the system. This is a useful feature that allows for quick and easy maintenance and improves system availability. However, not all RAID configurations support hot swapping, so it's important to check before implementing a RAID array. Parity. Parity is a form of error checking that is used in some RAID configurations to provide data redundancy. Parity information is generated and stored on one or more drives in the array and can be used to reconstruct lost data in the event of a drive failure. However, parity calculations can impact system performance, so RAID configurations that use parity may not be as fast as those that do not. Capacity. The capacity of a RAID array depends on the number and size of the drives used in the array, as well as the RAID configuration. Some RAID types, such as RAID 1, have a lower capacity because they require redundant storage for data. Other RAID types, such as RAID 0, have a higher capacity because they do not provide data redundancy. Backup. While RAID provides improved data reliability and availability, it is not a substitute for regular backups. It's important to regularly back up data to protect against data loss due to hardware failure, user error, or other issues that can affect the RAID array. Nested RAID. Nested RAID, also known as hybrid RAID, combines multiple RAID types to provide even greater levels of data redundancy and performance. For example, RAID 10 is a combination of RAID 1 and RAID 0, and RAID 50 is a combination of multiple RAID 5 arrays. Nested RAID requires more drives and can be more complex to set up. but it provides even greater data reliability and performance than single RAID configurations.